All right, I think that should be coming up shortly, I think. So yeah, hopefully. Okay, well, yeah, here it comes. All right, so yeah, 8:35, so we'll get started. This is COMP2404. You guys are the B group, Introduction to Software Engineering. And I'm Daryl Hill, the instructor. All right. So, that's the calendar. So yeah, we are here on the 21st of September. So some of you have done tutorial 2, some of you have attended the tutorial 2. It's on namespaces, which we will get to today. So, you know, hopefully those of you who went to this session, the TAs were told to be prepared with a little presentation if, you know, on namespaces. So hopefully, anyway, hopefully everyone got the help that they needed. So today we're going to yeah, finish up class definitions and namespaces. We're maybe half a lecture behind, but I think we should be able to catch up in short order. And yeah, I guess well on the way to being able to complete assignment 1. Yeah, any questions on the calendar? Okay. All right, so yeah, we're going to continue today talking about class definitions, and then we'll get to, so we've sort of, I threw a lot at you so that you had enough to do the assignment, but now we're going to go delve into greater detail into all of these things. So classes are, of course, a data structure that also has functions associated with it. So it's a set of parameters or variables and also behavior that's associated with them. So last class, I again managed to skip a slide, but so yeah, when we were talking about access specifiers, again, this thing, if I use page down, sometimes it'll skip slides. So I have to remember to use the cursor up and down, but just to come back to access specifiers for 1 second, it's important. They are important because, well, industrial grade software is typically huge, right? Millions of lines of code. Somebody asked me at some point, is it really millions? And the answer is yes. I think Windows is like 50 million lines of code. So it can be in the millions. Hundreds of thousands is not unusual. Lots of libraries and packages. So what you want is to protect your code from unauthorized changes. And it's not that there's malicious individuals out there. It's that if you make something public, somebody's going to think that they can make use of it, right? So maybe they'll change it and maybe use it in ways that you didn't anticipate and didn't want them to do. So they can, you know, sort of corrupt the state of your objects. So you want to protect your objects as much as possible. You want to give people access to your objects, but only in ways that you specify. And this is known as the principle of least privilege, which I have mentioned a couple of times, but it should sort of be the guide to all of our decisions when we're making a class. In terms of access specifiers, but also in terms of, in Java, it's sort of, because private things are private to that object. In Java, you know, getters and setters are sort of the norm, right? So you want to make getters and setters for all of your internal data, but in C++, they are not. You should only use getters and setters if the situation calls for it. So we don't want to default to getters and setters because we don't want people setting our variables essentially, or seeing the state of them and then trying to make a decision based off that. So we want to, sometimes it's necessary, and you do have getters in the assignments and the tutorials when it becomes necessary, but you shouldn't by default make getters and setters for all your member variables. Don't do that. That's against sort of the C++ code. And C++ makes use of other things, like if I have two student objects, then one of those student objects can see, and I pass one student as an argument to one of the functions of the other student, then student one can see the private member variables of student two. So that's sort of how that, that was the design decision there. Instead of always using getters and setters, they do that. Of course, some public access is necessary. Otherwise, as I mentioned last class, I believe, otherwise your object is completely useless. You can't really do anything with it. Okay, so we talked about that. We got to here. So yeah, the one other thing, so we came to this example where we took our student class from before and we separated it into a header and a source file. So there's one other thing I wanted to do with that example that I didn't do last time. So here we see student.h, and in here I have the class definition. So I declare the class student, except all of the functions are just function prototypes, right? So the constructor, which is really just a function, it just has the prototype. The print function and the isPassing function are just prototypes. And then I have the member variables. Now my student.cc, I have put all the implementation of all of these functions, and I've used the scope resolution operator to tell the, to tell the compiler that these functions belong to the student class. So now, and I've included student.h, so now the compiler can read the student class definition, get all the prototypes, and then come back here and say, oh, okay, I'm going to associate this constructor that was declared with this code here. And then so when it compiles it, and then you link this file, when somebody calls the constructor, it's going to say jump to some memory location, and that memory location is going to be wherever this code was stored. Okay. The one thing I didn't do, though, is include what are called header guards. So it's going to come up. I'll actually maybe do an example of it here, but I'll say if not defined, student_h. So that is that's the sort of format I want you to use, or that is the convention for header guards, is the name of the class _h in all capitals. So what I'm doing is I'm just defining this preprocessor. It's not even a variable, it's just a name, I guess. So what happens is the compiler will check to see if student.h has been defined yet. And if it hasn't been defined, then it will define it. It will read all of this, and then at the end it'll say, well, you've reached the end of the road, so that is all of the things this if statement covers. So the preprocessor goes through and says, has this been defined? And if it hasn't, then we know that this is the first time the compiler has seen this header file, right? Because in our application, we might include this header file in multiple places, right? I might want to use it in another class, say a university class, and I also may want to use it in my main function, or I might add it somewhere at a later time. So I might end up including this multiple times, and what I don't want, again, the compiler's sort of primitive. What I don't want to have happen is that if I let the compiler just read it twice, the compiler is going to go, why did you define this twice? That's an error, and then it won't compile. So this protects against multiple includes. Now I can basically include student.h wherever I want, wherever I use it, and not have to worry that it's going to be defined multiple times. So these are called header guards. All right. So yeah, all of your headers of all of your classes should include header guards. Okay. Questions? Perfect. Okay. And I'll try to come up with an example that will work for that, probably on this next one. So allocating classes. So this is something we've touched on a little bit. We're going to dive in a little more detail here. So when I use classes, I have a choice in how to allocate them. I can allocate them statically, or I can allocate them dynamically. So statically is wherever I declare it, that's where the memory is allocated. And dynamically means on the heap. So this is using the new keyword, and it always goes on the heap. The difference is, of course, if I statically allocate memory, then the life cycle of this object is handled by the compiler. When I dynamically allocate it, I handle the life cycle by using delete. This, of course, gets a little extra complicated with arrays because you can actually dynamically and statically allocate arrays, and then you can have arrays of objects or arrays of pointers. So for now, we're just going to look at statically allocated arrays, and then later we will look at the extra step of dynamically allocating arrays when we have a bit more of an understanding. So statically allocating array, if we statically allocate an array of dates, we still have, so date is a class that we're going to see shortly. We still have a choice in whether we statically allocate these objects inside the array or whether we make an array of pointers and then dynamically allocate them. All right, so, and the array of object pointers is, of course, more flexible in terms of, well, in terms of the life cycle, but also in terms of how I allocate them. We'll see an example of that. So arrays of objects automatically call the default constructor. That's not quite true, but that's true so often as to be, sort of the rule. But I'll show you actually how you can get around that. Okay, so I have here, let's get rid of some of this stuff. I have a date class. So we'll crawl through this a little bit, and then I'll show you, we'll demonstrate how to make arrays of dates and sort of the consequences of doing that, which we've touched on earlier, but we'll do it in more detail now. So my date class, in my date.h file, I have my class definition. I have my header guards. I include IOStream and string, and I use the standard namespace, just everything to make it work. So here I have 3 constructors. So we haven't talked about copy constructors too much yet. So we can kind of, we'll just ignore this for now. This is a copy constructor. I take a date that already exists and I make a copy of it. We'll get to that shortly. But I do have a constructor that takes a year, month, and a day. And then I have a no argument constructor. So I have 2 constructors, and then I have a bunch of setters. I said that, setters are a bad idea to default to, but for my date class, of course, I might want to change things like the month or the day or the year. So I do have setters because it's appropriate in this instance. Not only that, it allows me to do a little bit of sanitization of the input, right? If somebody says a day and gives me the number 40, I can check for that to make sure that, okay, I want to make sure that I have a proper day, that, if my month has 31 days, then it should be between 1 and 31. So I have set day, set month, set year. I have set date. That takes 3 ints, and then I have a set date that takes a date reference. So here I would also make a copy of this date. I have a function get month name. So when I set my month, it's a number from 1 to 12. And then this get month name will return a string that gives me the associated name of that month. And then I have a print. I also have a private helper variable called get max day. So assuming that I've set the month, it will give me the maximum number of days in that month. Yep.
I was just wondering, whether for the setters, it would be like more appropriate to use like protected, but I'm not sure if that would like be useful or it would only make things complicated. Because I don't know, like I'm thinking like, yeah, it's public. Like if it was like in a real world sense, it's like other people would have access to that, can set dates like however they want.
Yeah.
Also want to like, I mean, that's for like future stuff like inheritance and stuff like that. Like,
yeah.
maybe protected might be better, but I'm not sure. I'm just thinking.
Yeah. No, it's good to think about these things. And the answer to that is really, it depends on the application, right? So there are, maybe I write an application where I'm cool if you change the date, that's fine. Maybe I want you to change the date, but others, I want to control that. So yeah, I'm sort of making an arbitrary decision because it really depends on what my needs are. So yeah, you're right. It's good to think about because yeah, perhaps I want to make a date. Once I make a date, I never want to change that. And if you want to change it, then you just make a new date. That's also a good idea, right? Because this one, somebody can come along and corrupt the data, basically. So yeah, so it was an arbitrary decision. Okay, other questions? All right, so my date source code. So I include my header file. So date.cc, the first line is include date.h, of course, so that the compiler can read the class definition and then verify that I've implemented these correctly. I have the correct signature, and then it will compile it into an object file. So I have here, this is my 3-argument constructor, and I just call the set date function. So this just makes it easier. So I sort of consolidate all of my setters together. And I rely on code that I've already written in order to initialize my member variables. So we'll see what set date does in a second. My no argument constructor, I just call set date with 1901 January 1st, right? So I've arbitrarily decided that's the earliest date I want to represent. This is my copy constructor, which again, we're going to get to a little bit later. So my set day, set month, and set year, you can see that we do all of the checks, right? So set day depends on, I have to have set month done first, but we're being a little bit careless with this class because this is just a demonstration class. But yeah, when I call my setters, the set month gets set first. So I check to see if it's between 1 and 12. And then once I do that, I can find the maximum number of days in that month. And then I can make sure that this number falls between those two. So if it's too big, I just set it to the max day. And if it's too small, if it's less than 1, I just set it to 1. And then I use that to initialize my day member variable. Same with month, I make sure it's between 12 and 1. And the year, I just make sure that it's 1901 or later. So yeah, this is the type of, in your assignments and things, when I say, make sure sanitize your data, this is the type of, or error checking, this is the type of error checking I would expect you to do. Make sure things fall in the proper range and things like that. My set date just calls set year, set month, and set day, right? So I rely on the error checking of these setters anytime I want to change the date. And then here's a set date that takes a date reference, and all I do, so you can see year, month, and day are private, but because this is within the date class, this is a date object in my date class, I have access to these private member variables. The compiler is not complaining here because this is allowable. And this makes, things like copy constructors efficient in C++. Here's my get month name. You can implement a get short month name, and you can do these, you can return these shortened versions. I didn't bother to do that. I'm just keeping it simple here. I put them there because, at some point I could change months to S months, but all it does is it makes this array of strings and then returns the correct one. There's better ways to do this. We're going to see later, this is the simplest way because of the level that we're at right now. We don't know how to use static variables and the consequences of all that. So This does work kind of well in terms of memory management because these are all stored in the, these are all hard coded, right? These are in the, what's it called? The text something or other. But these are stored in memory as character arrays. And then each of these strings just has a pointer there. So this sort of actually works pretty well. It doesn't allocate a bunch of memory that it doesn't need. Well, a little bit, but not too much. And then I have my print function, which simply gets the month name, prints the day and the year. And my get max day uses a switch statement. So I switch on the month. And then if it's month 4, 6, 9, or 11, I return 30. If it's February, I return 28. And by default, everything else gets 31. I could have included a little bit of code here for leap years, but I didn't. Again, I wanted to keep this sort of simple. So yeah, this is a date class, and this is the date class that you get with your assignment 1 that you have to then make a wrapper for using the reservation class. Yeah, questions? Good. Okay, and then, so I have my date and then I have a main. My make file simply compiles main into an object file, date into an object file, and then links them together into a P2 executable. Perfect. Okay, so let's see what it does. So the first thing I'm going to do is statically allocate 2 dates and then print them out, and then call set date just as a sanity check to make sure that everything's compiling and working correctly. So let's remake that. So I made a date D1 2020, so September 9th, 2020, and then I made a date D2 that calls on the default constructor. So one thing to watch out for, if this was, when you declare a new object in Java, for instance, you always include the brackets. Here you do not. So if I put the brackets here, you can see that this turns from blue to yellow. And then I get a bunch of errors popping up because it's trying to access this and it doesn't know that it's an object. So this is actually ambiguous in C++, right? Because this could be forward referencing a function called D2 that returns a date object. So yeah, if we are using the no argument constructor when declaring a date, don't put brackets. All right, it's confusing to the compiler. There's a few situations where things are, because there's so much notation or so much the syntax in C++, a lot of it is reused, and there's actually these ambiguous things that come up from time to time. So yeah, this is one of the compromises they made. If you declare a date, don't put the brackets. If you declare a date with no arguments, don't put the brackets. And that applies for any object. Okay, P2, so September 9th, 2020. I don't know why 2020, but, and then I made D2 is just the default. So D2 is January 1st, 1901. D2, I set the date to September 16th, 2022, and then I print it again, and then I exit. So everything seems to be working okay. So let's look at some arrays. So yeah, statically allocated. So I have a statically allocated array of objects here. Now, when we tried to do this with the student class earlier, we had trouble. It wouldn't let us. But in this case now, I have a default constructor for the date class. So now I can statically allocate an array of dates. So what happens is, let's say I have 3 of them. Each of these is a date object, so there's enough memory allocated for each of these date objects. And then because they are classes, they have to be initialized somehow. Or if I provide a constructor, I'm telling the compiler that, hey, you have to call one of these. If I don't provide a constructor, you get a default constructor a default no argument constructor, and the compiler goes through and just allocates memory, and it will call the default constructor on any member variables that have one, but everything else it just leaves. But here I provided two constructors, so when I make all of these date objects, each of these has the default constructor called on it. All right, so I can do that in this case as long as I have a default constructor. So I have my max size is 3, so I make an array of 3 dates, and then I can print them all out. Okay, so printing out the 3 dates, the default constructor was called on each of them, so each of them has January 1st, 1901. If I didn't have that default constructor, that statement would give me trouble. There's actually a way around it. I can do this. I've declared arrays of strings like this you saw with the student class. I had an array of string names, and I initialized them all within these curly braces. You can do the same thing here. You can say 2022, 0, let's say 10, Halloween. So I can actually, let's just keep this simple. I can initialize it without a default constructor as long as I provide the object. So I say this date you should initialize using these arguments. So if I don't have a default constructor, I can still initialize an array of objects this way. You don't see that very often though, because typically if I make an array of students, it's going to be, 30,000 students long. So this would be very difficult to initialize all of your students that way, but it can be done. I call it backside. Okay. And then I can set the dates of individual array objects. I guess this is a lot of this we did last class, I think. I didn't really intend to, but I got carried away. So some of this is kind of review, but I can access individual array elements, right, using the dot operator because these are objects. So I reference the array variable. I use the square braces and the index that I want to access, so 0, 1, or 2. And then I call the dot operator to call on one of these date functions. So in this case, it's set date to 1922, and this is setting it to 1933. And then I can print them all out again. So yeah, February 2nd, 1922, March 3rd, 1933, and the third one still has the default values. So yeah, statically allocated array, this is the type, this is the name, and the fact that it is an array comes from these square braces. Okay, again, there's a bit of review, but any questions? Okay. Statically allocated array of pointers, which we've also seen, but in this case, it's the same way. I declare it the same. This means it's a statically allocated array, but now the type is different. The type is date pointer. And now in order to allocate a new thing here, so in my array now, these are date pointers, which the compiler knows how to initialize these. Basically, it does nothing because these are just memory locations. So now there's no dates associated with this, but now I can say, well, I say, well, in the first location, assign this new date. So when I call new date, over here on my heap, I allocate enough memory for a date object. I call the appropriate constructor. I initialize all those values. And then that memory location is returned to this pointer. So now this pointer has the value of whatever the memory location of this date is. And then, of course, I did that a second time. And this one got allocated. This guy is still pointing to probably 0, but or whatever garbage happens to be there. So this is the state of my date array at this point. So it's an array of date pointers, and 2 of them are pointing at something useful. But yeah, it's very important when I make an array of pointers. These are all pointing at garbage unless I tell it specifically to make new dates in this case, or whatever object you happen to be using. And I make new objects and assign them to those pointers. If I don't do that, it's just pointing at garbage. So yeah. Okay, so I assigned 2 of them a value, and then I tried to print them all out using a for loop up to max size. So I tried to print out locations 0, 1, and 2. I got January 1st, 1901. That's fine because I used the default constructor. Then I had October 31st, 2022. I used the 3-argument constructor, but I didn't initialize the 3rd location, so I got this segmentation fault. That won't always happen. Sometimes if this is pointing to something, whatever garbage was left here, maybe a location on the heap, maybe a location on the stack, but the compiler might be able to follow this and interpret what's there. And then you'll get some really weird error because it'll read maybe a negative, 2 billion or something, and something sort of undefined will happen. So these are dangling pointers like this are dangerous in C++. They're really hard to find. If you get a segmentation fault, you're lucky, actually. You don't always get them, especially if you do this and then delete this, you can still run into trouble. So let's initialize the 3rd one. And then print it out. And now I have September 16th, 2022. So because these are pointers, I, of course, have to use the, in order to follow the pointer and access the members, I have to use the pointer operator instead of the dot operator. All right. Questions? Okay, let's see if we can. I just want to see if we can fool the compiler here. So I'm going to delete this one that I just allocated, and maybe it'll still print. Maybe. Yeah, so it did still print. So I fooled the compiler. I deleted that last one, and then it looks like something overrode it for some reason. So it still followed the pointer at location 2. This was pointing to something in memory, right? And then I deleted it, which means that, okay, all that happens is the heap says, okay, I can overwrite this location now. Before, these were all protected locations. Now it says, I'm free to overwrite it. And it looks like somehow it did. And then when we followed that pointer, we got May something weird, right? So if you see numbers like this is often you have a pointer that's pointing to something garbage, but that didn't quite trip up the compiler. The compiler is like, oh, this seems okay. So yeah. All right. Questions? Okay. I think that comes later. Okay, so a couple of things. Again, I've touched on a lot of this before, but the C++ compiler is deliberately primitive, right? And the reason why is that it wants to allow you to do clever things. So it doesn't organize the code for you. It just starts reading and then follows any includes that you have and keeps reading all in a straight line. Anything clever you want to have happen, you have to make it happen. So when I'm compiling the date class, it starts reading date.cc. It sees this include date.h. It jumps to that file and continues reading. And then once it's done reading, it comes back and then sees that, okay, here's all the implementations, so I can compile these now. So when you're including all of these files, as long as you use your header guards for the assignments that we're doing, you're probably not going to run into too much trouble. But it can happen that you have to organize your make file and organize your includes a little bit better. So you should, if you get a really weird error, you should think about, like, if it says something's not defined and you think it is, it might say that your class is not defined. Then you should try and think like a compiler. So what happened? It starts reading here, it jumps to this file, it jumps to this file. Generally, what happens if you get that class not defined when you've defined it, maybe you've included, you have your class A, you've included class B, and class B has included class A. That can often happen. All right, class interfaces. So in C++, when we talk about an interface, so Java has a specific thing called an interface, and it's very similar. It's basically a bunch of function prototypes. So when we say class interface, that's what we mean. We basically mean the header file, so the definition, so the different functions and how we call them, and the public functions, right? So interface means, how do I interact with this class? So I look at the public functions and say, oh, I can print it, I can initialize it, whatever. So that's the interface. So class name and all of the public members. In C++, this interface is in the header file, and there's some additional information there too. It's not in the public interface. There's the private member variables and stuff, but yeah. So to use a class, we have to include the header file in the source file, right? So the header file, it should say in the source. Never vice versa. If you do vice versa, it's gonna, it'll work, but will it work? It'll work as long as you compile the header file and not the source file. But anyway, it's going to create problems. So yeah, include the header file in the source file. It contains the public interface. It's enough information for the compiler to ensure you use the class correctly. Sorry. You know what? I read that wrong. When I'm compiling my source file, I include the header file in the source file. When I'm using a class, I just include the header file, and then I link to it later. So when I include the header file, it's like I'm forward referencing this class. And then, yeah, when I want to make an executable using this class, I link my code to the object code of that class. So if I want to use the date class, I include date.h. Date.o is somewhere in my file directory. When I compile my completed executable, I'm going to link that date.o. I never need to include date.cc. Yep.
So say for like the main.cc and you're using like the date class, you don't have to put like include, like hashtag include date.cc. All you have to do is just include date.h, and then you link the object file to your main, to the command line in your main file, basically.
Yep, exactly. So here I'm using date everywhere, but I've only included date.h. I could include date.cc, but of course that defeats the purpose of compiling everything separately. Now every time I recompile my code, date.cc is going to be recompiled, and it's inefficient. So yeah, I have my date.h. That's enough for the compiler to go through and compile this into an object file. And then when I want an executable in my make file, I'm going to link date.o to my main.o, or I can link it to main.cc in one step. That's, we will also accept that, as long as you're compiling all of your classes into object files, right? And this format for compiling into an object file is what you will use for all of your classes. It should look exactly like that. you just substitute your class name in here. We'll see you'll end up with a bunch of object files. So one way to help with that, so that your makefile stays more organized, is to use variables. So we'll see variables coming up shortly. All right, other questions? Okay. Yes, so code organization. So when you write a class, who is using it? Well, almost certainly other developers, right? There's very few forward-facing, user-facing classes. There's a couple, but most of them are support classes. So even when writing end-user code, you may want to have APIs or something for other developers to contribute. So your classes are going to be looked at by other developers. So other developers need to know the class name, public members, so the public interface, basically how they can access it, description of the functions, and sometimes protected members if they're going to subclass your class. All right, so yeah, this is sort of what we just went over. So I'm the developer of a class, say date.h. I make my class definition, my header file, and I make my source file. So now when I compile it, I'm going to include the header in the source file. I'm going to compile the source file into object code. And now I have date.h and date.o. I give date.h to whoever's going to use it. So this is developer number 2, the class user. They're going to use my date object. So they're going to include that header file. They're going to compile their code into object code. And then when they want to make an executable, they're going to link the object code that I give them. So I can give them, what I give to somebody else is the date.h and date.o. I can keep date.cc for myself. They don't need to see that. If we change our source code, we can recompile it. And then all this guy has to do is say, I tell them, look, I've recompiled the source code. Here's the new object code, and they relink it. That's very fast for them, right? All it is they're plugging in a memory address to a new piece of code. The other thing, make sure you include your header guards. This guards against multiple includes. You know, as your program grows, you know, initially you can sort of keep things organized so that you don't get these multiple includes, but as your program grows, you're going to end up, you know, including multiple header files, and those will include other files that include those original header files, so you'll get this multiple definition problem. So header guards will protect against that. Don't include the source code. It makes you recompile unnecessarily. So yeah, this is frowned upon. Mostly, right? C++, there's always an exception to every rule. So sometimes we do actually include the source code. This primarily happens with data structures using templates, if I remember correctly. You can get away with not including the source code in the header file, but it makes your life very difficult. So it does happen sometimes. So yeah, you should understand what belongs in the header file, which is essentially your class API. It's your public interface. All your source files should be compiled separately. So each class that you make should have an associated .o, an object file, separate one. And then users of your class will only have to relink your code if you fix a bug or whatever. All right. Source files contain all class-related source code, so all of the implementations. By default, all of these functions are global. So it's very important to remember to use that scope resolution operator, right? So for our student class, it was student, and then the 2 colons. So that means this function belongs to this class, not just class. We'll see it's also namespaces, but this also lets the compiler resolve the visibility of variables and other functions, right? So if I have private variables, the compiler will realize that that they're private. or identifies static data, member initializations. So we're going to see that a little bit later when we get to static variables. So variable scope refers to where in the program a variable is visible. We've seen this already. We're going to look at one or two other cases, but mostly it'll be a repeat. So block scope, this includes class blocks. File scope, it's outside of any block. We can label pieces of code in C++. We're not going to do that in this class, but that does have its own scope as well. And function prototype scope, again, we can do something like this. I can use one of the previous parameters in the function declaration in one of the following parameters, right? So we're not going to do that. That's a little bit advanced. But yeah, that is the two different types of scope that we're not going to get into. So yeah, a variable declared within a block has block scope. We've seen this. It's visible to the block in all inner blocks unless we've shadowed it, right? Unless we've declared another variable with the same name. Once we exit the block, the variable disappears and its value is discarded. Yeah, so we talked about shadowing. Try to use unique identifiers. You can always access variables that are global so that they're at a file scope using the unary scope resolution operator. So unary just means it has one argument, right? So I'd say if I do this, this means there is a name global variable, you should access that. Yeah, so if I declare a variable in file scope, so we're going to talk a little bit about global functions, global variables. And I'm going to give you the tools to use them. We're not going to use them very much in this class, but if I declare a variable or a variable is declared somewhere else and I want to access it, if it's a global variable, I have to forward reference it, right? Same as a function. Of course, if I forward reference a variable, it looks like I'm just declaring a variable. So I use the extern keyword to say, I'm not actually declaring this variable. What I'm doing is saying that there's a variable with this exact type and name somewhere else. So P3. Okay, so this is basically code that we've seen before, but we're going to add a little bit to it. So this is the scope of variables. So here I have a global variable X, and then I hide it in various ways. Again, you've seen this, I think. All right, so that's not so interesting. Here I've declared this is leading into namespaces, which is why we're reviewing it. Because namespaces, all of these different scopes are important. But here I have basically a block for no reason. And inside that block, in this floating block, I can declare local variables that only function inside that block. So let's, if true, let's get rid of this. I don't think we need that. And then we will come back to these later. Okay, so in main, I have my X, that is my global variable. And so when I print it to the screen, it prints the global variable. And then I declare a second X that shadows that first X. And then when I print out, when I print out in main again, it has that new value for the local variable. Okay, so this is called shadowing. So now, I've hidden this X. And then in here, actually, let's execute this. There is something useful to say here. Okay, so in the if, I've again, I've assigned the value 30, and now it's, yeah, so it changed the value of that X. But what happens if I declare another local variable? is that this again shadows this. So I could come across this situation where I actually want to resolve this. So in this if statement, if I declare a local X, I've lost this guy. So what I want to do is have some way to say, well, I might have naming collisions because I have lots of code. So how am I going to resolve these, right? I don't want to declare a variable that accidentally shadows a function from a library that I've imported, right? So we're going to see how namespaces solves this problem. Here I have a name alias, floating block local, floating block global. So the name alias is what I want you to pay attention to here. So what I'm going to do is I'm going to say, if I wanted to say, let's see, I have a file ext.cc and I have in here a name Billy the Kid. Okay, I have some other stuff that's going to be used in the next example. So this is just a source code that declares a variable, a global variable. And I want to use this in my program. However, if I just, so I would normally forward reference this if this was a function, and I would say string name. Right, so let's do that. However, the compiler can't tell the difference between I'm declaring a new variable name or I want to use the variable in this ext.cc, which I'm going to link to later. So I've compiled it and I'm going to link to this. So what I put is extern. Okay, so now I have, let's get rid of all these X's. So I want to output the name now. Let's get rid of up to here. We don't need. Okay. So I have my global name that's external, and I'm going to make, I think I linked to it, but maybe not. Okay, so I didn't link to it. So it doesn't know. I told the compiler, hey, there's this external string called name. I don't have it for you right now, but I'm going to give it to you later. And then in my make file, I did not give the compiler that string. So it says, well, I don't know what you're talking about. So what I'm going to do here is link. I'm going to say it depends on this, and I'm going to link it. So that string name variable gets compiled and then linked, and now I should be able to compile it here. Okay. That's not what I wanted. Okay, so I declared this name, and then when I print it out, you'll see I get Billy the Kid. I should have put an end line here. So I declared this external string name. I linked to it later. It's essentially a forward declaration of a global variable that is coming at another time. Inside the floating block, I can call the local name. So I've shadowed that name now, that external variable with alias. So I can print it out. And then since this is a global variable, I can use the unary scope resolution operator to access that external name variable. Yeah, all right. I really regret leaving those ints in there. It's kind of cluttered things, but yeah. So I have a string name. It's a global variable in another file that I wanted to use. So I forward referenced it using the extern keyword, which is a promise to the compiler that, hey, there is a name variable that is defined somewhere else. I'm going to give it to you later. And then I link to the object file that contains that name. All right. So yeah, questions? All right. Yeah, I think that's all the lessons for this one. So then Okay, so namespaces. So what is a namespace? It's not a class, it's not a package. It's the closest equivalent would be a Java package, but it's more flexible. So it has properties of both of those things. The definition is that it's a namespace is the definition of a named scope. Basically, it's to resolve these naming collisions that we have. So to use an element from a namespace, I scope it in by using the using keyword or the scope resolution operator. So we've seen using namespace standard, STD. We've been doing that to make our life easier, but I can use that using with any namespace. Or I can explicitly declare this namespace so that the compiler knows that the cout should come from the standard namespace, not whatever I've redefined it as. We can also have unnamed namespaces. Then these are automatically scoped in. And you might say, well, what's the point of an unnamed namespace? The point is we're declaring, it's called internal linkage, which means that basically these, if I declare some variables in an unnamed namespace, then these variables are global only within the scope of this file, right? So this is one way that C++ gets around this global variable thing. You will actually, if you program in C++, probably see that used. So it just means that visible only to the current translation unit, which is the, let's say my translation unit is date.cc. So it's visible to date.cc and the header file and all of those things that are included. So a translation unit is basically everything that is compiled into an object file. So unnamed namespaces are used to have local global variables, essentially. All right, and then, yeah, so let's look at the. Okay, so here I have, let's say I'm tracking the employees of a video game store. So I have my manager, I declare as a global variable. And then down here, I have an unnamed namespace, right? These are, again, these are in a global scope. So these will be global variables, but only for this particular .cc file. So I've shadowed now my name, my manager. I have a cashier and a stock person. So these are all global variables in the context of this file. We'll get to this stuff later. Maybe I have another location. So this is the, these are the manager, cashier, and stock person in my main location. Maybe I have another location out in Orleans. So I'm going to declare a namespace Orleans. I have an open block, open brace, closed brace. Unlike classes, I don't need that semicolon. And then at my Orleans location, I'm going to have a different manager, a different cashier, and a different stock person. I'm also going to declare a function called print employees. And inside this namespace, I'm also going to have a second namespace. So at this Orleans location, I have this demo booth where people can go in and try the different games. So yeah, I have an enumerated type called consoles, Xbox, Switch, and PlayStation. So we don't use enums too much in this class, although feel free if you want. But enumerated type is simply, I'm associating a bunch of integers with these names, right? So I can actually use them as integers, but typically they're simply, I want to be able to use a switch statement on these or something like that, or maybe iterate over them. So yeah, these act as iterable names, enums. Anyway, just for fun, we're using it here. Again, we don't get into it too much. We could talk about it more if you like. So I have a namespace Orleans and a demo booth, and then I start my main function. Okay, so let's run that, see what happens. Okay, so my cashier for my unnamed namespace, I have access to this variable. It's global within this file scope, and it is William H. Bonney. And my original manager, you can see that I use the unary scope resolution operator because I have this naming collision. Sorry, not that one, but this one. So my unnamed namespace manager collides with my original manager. That's a global variable. I can always scope in the global variable. However, accessing this now is going to cause me problems. So if I want to try and access the manager from the unnamed namespace, the compiler doesn't like that. So it can't figure out whether I mean the global variable or the unnamed namespace. So essentially, yes, by redeclaring a global variable with the same name in an unnamed namespace, I've essentially made this one useless. I can't access that anymore. So yeah, one thing to avoid. And yeah, so now I can access the manager from the unnamed namespace. So this is now the global manager. I only have one manager. Okay. Now, if I want to see who's the manager, the stock boy, the cashier at the Orleans location, I'm going to scope it in using the scope resolution operator and say, well, I want the manager from Orleans, the cashier from Orleans, and the stock person from Orleans. Okay, so from Orleans, my manager is Wyatt Earp, right? So we can see that here, the cashier is Doc Holliday, and the stock person is Virgil Earp. So this is, again, it's not a class, it's not a package. It's simply, I'm saying, I want to avoid naming collisions, so I'm going to give an extra name, an extra layer to this, to these declarations. All right, questions so far? Okay, so this is fairly simple. So let's look at what happens if I want to access things from the demo booth, my enums. So I'm going to print out my Xbox enum. To do that, I'm going to scope it in twice, once for Orleans and once for demo booth, right? Because it's a nested namespace. All right. See when I print them out, P4. So yeah, my Xbox has the number 101, my Switch has the number 102, and my PlayStation has the number 103. So these look like basically constants or a different type, but they're actually, you know, they're just integers, but we can use them as types. Again, this helps your code to be more self-documenting, right? If we use enums instead of just integers. But yeah. All right, questions on that? Perfect. Okay, so let's look at our print employees function, right? So originally I said, well, there's a print employees function in my Orleans namespace. Now, similar to my classes, when I want to, you know, define the implementation of my print Orleans function, I have to scope it in with the scope resolution operator. Otherwise, the compiler thinks it's a different print employees function. So I say Orleans, exactly as I would with a class, and then I can print out all the employees. So here I printed, all right. So I printed, I've only used manager, cashier, and stock. I do not have to scope these in because I'm already in the Orleans namespace. So when I print now, whereas here I have to put Orleans print employees. If I don't, yeah, the compiler doesn't know what I mean. It says that's undefined. Orleans print employees, okay, I know what that is. That's in the Orleans namespace. Okay, so printing employees from Orleans, Wyatt Earp, Doc Holliday, Virgil Earp. Again, they're already scoped in here. If I want to now print out the demo booth numbers, I do have to scope those in because although I'm in the Orleans namespace here, I'm not in the demo booth namespace. So I do have to scope those in. But if I do, then I can access them as I did before. And on top of that, I can access my unnamed namespace, which is sort of global variables that are local to this file, using the unary scope resolution operator. So I just have nothing out here, and I can access those, the employees from the original location. Right, so the old manager is Jesse James, the old cashier is Billy the Kid, and the old stock boy is Pat Garrett. Okay, so that's namespaces. So they're like classes, but they're more flexible. I can just have a namespace for no reason whatsoever, and just add functions and variables to it. I can nest them. I can add classes to it. I can do whatever I like. So yeah, any questions? Yep.
So if you're testing them, the location, like similar, you just use those two columns.
Yeah, so just as we did up here, so because none of these were scoped in, I have to use, yeah. I first scope it into the Orleans namespace, and then I scope it into the demo booth namespace, and then I can access this Xbox. Yeah, so however many I have, that's how many yeah. I have to name them all unless I scope them in using the using. Yeah, other questions? Okay, so let's see what happens when let's say I want to scope in using namespace Orleans. This actually causes a lot of problems. Cashier is now ambiguous. So because I said using namespace Orleans, even though I put it below my main function, it's still at file scope. So this actually using namespace, whatever, if I declare that at file scope, then it applies to the entire file, right? It's not, the compiler doesn't play dumb in this case. The compiler goes through, pre-processes that, and then applies it to everything that happens above and below it. So declaring it here is no different from declaring it up here. Right, it's exactly the same as far as the compiler is concerned. If I declare it inside, let's see. If I declare it in here, okay, so now it says cashier is ambiguous because I've scoped in Orleans, but I've already had the unnamed namespace scoped in. So now I have two cashier variables here. But yeah, I can scope it into my main function by using the using clause. So there's a lot of variation you can do with it. But typically it's just to resolve naming collisions. And organize your code into packages, let's say. All right, questions? Okay, 10 minutes left. Okay, so that takes us to the end of class definitions. So the next thing we're going to look at in more detail is constructors and destructors. We have 10 minutes, so we'll just get a little start on this and then continue it next class. So constructors, I think hopefully you have a good feel for already. So you do need those for your assignment. Destructors, you don't have to use on your assignment, but if you want the bonus marks for cleaning up your memory, you'll probably want to use them. But you should have enough information to get a pretty good start on your assignment. Right, there's, yeah. If you're having trouble with the make files, there's all the code that I give you guys for the classes, this stuff. It's on Brightspace, just download it and look at the make files from there. And you'll get a lot of hints onto how to, how to do that. Okay, so we're going to talk about, default constructors, which we've talked about, but also default arguments. So in any function declaration or, well, any function declaration, I can declare some arguments as being default. And so we'll see what that looks like and how we use it. Destructors. So destructors are like the garbage collector in Java, except that we control how things are destroyed and what resources are released. We're going to look at order of invocation of constructors. So this becomes particularly important when we have classes that contain other classes or when we're using inheritance. So the order that the constructors are called in matters, because you have to know what you need to initialize and what's already been initialized. We're going to look at copy constructors. We've seen them already, but we will talk about how they're used. And then conversion constructors, which are a lot like copy constructors, but I'm converting one type of object to another. All right. We'll start with the default arguments. So an argument is a parameter value, right? So my date class takes 3 arguments, int. I can assign these parameters default values. So this has a lot of flexibility in how I call my date function. So if you've used Python, Python uses default arguments as well, and it basically does the same thing. There are no default arguments in Java 8. I think the more recent Javas probably have them. I don't know, it's always evolving. So I'm guessing at some point they threw in the towel and went with default arguments. But if you're programmed in Java 8, then you would not have used default arguments. Properties of them, we specify them in the function prototype. Okay, so not in the implementation. If you put a default argument in the implementation, the compiler is going to yell at you. You can have as many default arguments as you like. However, they always have to be the rightmost arguments of a parameter list. Python's nice because you don't have to do that necessarily. I don't think you have. I can actually name the parameter name and assign it whatever argument I want. But C++, we still do it the old-fashioned way. All right, so let's see here. Let's take a second to load this up. Okay. And example 1 is simply default arguments in functions. So what we have here is, let me just get out of here. Okay, good. All right, so we have simply a source file with a main function, and then I have a function called do the math. So what happens is I supply it 2 arguments, an x and a y that are both floats, and then I have a character that is an operation that I want to have performed. So this would be the division operation. This would be multiplication. I can do addition or subtraction. So I forward referenced my function here, and then down here, I have the implementation. So I use just basically a bunch of if statements. If it's equal to multiplication, I'm going to multiply them together and put that in my answer. If it's subtraction, I'll subtract them, etc. And then I output it. So I don't have any return parameters here. I simply do the operation and I print it out right away. So yeah, let's see what happens when I do that. Okay, so 2 divided by 2 is 1, that's fine. 1 divided by 2 is 0.5, that's also fine. 10.5 times 20 is 210. It sounds right. So yeah, and there's a little bit of formatting. I used fixed. I forget what fixed does. But set precision gives me the 2 decimal places. So yeah, I can format it a little bit of formatting here. I'm not so great at it, but it is nice. Nicely formatted output is something. So yeah. So any questions on this part? Everybody understand what we're doing? Okay. So let's say now though, I don't always want to supply the operator because mostly I just do addition, right? So what I'm going to do here is say, let's make that a little wider. Okay, so I'm going to say the operator, if I don't supply the operator by default, it'll be plus. Okay, so I'm just going to say, I declare it, I have an assignment operator, and I tell the compiler what the default value is. Down here in my implementation, I leave that alone. I don't put any default arguments here. The compiler does not like that. But once I do that, I can say, take that one away, take those two away. And now when I call do the math, it's going to say 2 + 2, or it's going to say 2, 2, and then, well, since I didn't supply an argument, this is going to be plus. So yeah, so 2 + 2 = 4, 1 + 2 = 3, and yeah, 10.5 times 20 is 210. All right. Okay, so a couple of no-nos. This one we've already talked about. If I do this, let's see if it complains. No. Let's try making it. All right, so yeah. So my Visual Studio Code didn't catch it, but the compiler sure did. So it did not like that. And if I took that away, it would still complain. So I have to declare it, or I have to say, yeah. So default arguments have to be put into the prototype, not the implementation. The other thing, the other no-no is that, let's say that I want to always supply the operator, but I want to make this by default 2. So maybe I often add or multiply 2 times some other number. Well, you can see right away that Visual Studio Code is complaining, saying the default argument is not at the end of the parameter list. Right, so it has to be, if I have a default argument, it has to be to the far right. So that doesn't work. However, if I have 2 default arguments, as long as they're both to the far right, right? So now it works because my operator, again, has a default argument. And this is to resolve basically, if I have 2 default arguments that are the same, and then I call it, or let's say, well, essentially, if these were both floats, and then I called do the math, then if they weren't all the way to the right, the compiler wouldn't know which one I meant, right? So yeah, it's just to resolve that situation. So now I have 2 default arguments, so I can call this with 1 argument if I wanted to. Yeah, so 1 + 2 is 3, 2 + 2 is 4. What I can't do, of course, is this. Or will I? I think it's going to automatically convert that to a float. Let's try it. Yeah. So this, although it looks like I'm supplying an argument to my operator, it's actually just converting a character into a float and saying 1 + 43, which is the ASCII value of that. So yeah. They always have to be to the far right, and they always have to be in the prototype. And that's it for today. So next class, we'll talk about using these default values in classes, in particular in constructors, and how that we can have a default constructor and a normal constructor all in one because we give it all default arguments. Yeah, that's it for today. What day is it today? Wednesday. Oh yeah, I guess I'll see you guys on Friday. Yeah.